Okay, so we're looking at section 2.2. This is part 2, or part B of the video that we're looking at. So we're picking up its slope, right?
Yes.
So what you have found is slope is what? Y sub 2 minus y sub 1 over x sub 2 minus x sub 1, correct?
Yes.
All you have to do is you've got two ordered pairs. Make one group 1, the other group 2, right? So here's group 1, here's group 2. And in doing that, this becomes x1, y1, x2, y2. Now they're substituted in, right? Y2 is negative 7 minus negative 4 over negative 1 minus 3, right? And when you subtract the negative, it becomes a, so that's negative 7 plus 4, which is negative 3. And negative 1 minus 3 is negative 4. Ladies and gentlemen, clean up my signs and reduce my fractions. So negative 3 over negative 4 becomes what? 3/4, right? Any questions?
Where's our negative sign go?
Right here?
Negative.
Negative divided by negative is a
Oh.
positive, right? All right. So,
Is that like the answer?
yeah, that's it. Find slope. Yeah. So this is traditional, right? So the most common mistake that you'll find in this right here is people crisscross or picking the wrong coordinate, right? So I like to do this. I like to take my ordered pairs and I like to stack. When I stack them, what that helps eliminate is pulling from the wrong ones, right? So I look at it in terms of this, changing x and changing y, because y2 minus y1 is a change in y, x2 minus x1 is a change in x. So basically, I'm looking at it in terms of a number line. From 3 down to negative 1 is 4 on the number line, 4 moves, but it's in the negative direction. That's where the negative 4 comes from, okay? And then from negative 4 down to negative 7, right? Hear that down? That tells me I'm going in a negative move, and it's negative 3. And then all I have to do is slope is changing y over changing x, so that's negative 3 over negative 4, ladies and gentlemen. Clean up my signs, and we are saying right back to the same thing. Yes, ma'am.
So is the slope always going to be positive, or would the answer was positive 3 over positive 4 would change to negative?
No. No. Because depending upon how you grab this, the question was, do we have to change it to a negative, right? No. If you were to choose the other set that would have made it be a positive 3 over positive 4, then you wouldn't have to worry about simplifying your signs, right? Does that make sense?
So it's always positive.
No, ma'am. Slope can be positive or it can be negative as a numerical value, right? Like, for example, you owe me $5, right? That's negative 5. If you're in the hole $5, that's negative 5. If you're in the good $5, that is a positive 5. So there's negative and positive associated with inference on where things are. Same thing with slope, right?
How would you know? I guess I don't understand. How would you know when you would have to change it from a?
Okay. So let's look at this. Find the slope of the line through the following pair of points and draw the line through the points. Well, the first thing you need to do is what? You better do what with these 2 points? So you need to plot them, right? So go plot them. Take about 15, 20 seconds, go plot them, and see if you can find slope based off what you plotted. Okay? So we'll give you a little bit of time. Okay. So looking at this, you should have been able to plot your points, right? Y'all agree? All right. Now, you've got 2 things that you can do for this. Once you've got your points plotted, you can go ahead and plug it into the slope formula, right? Y2 minus y1. You assign one as group 1 and the other is group 2, right? That's fine. Or you can do an analysis on the graph, because slope is rise over what? So anytime I have 2 points, I will draw a triangle, or part of a triangle, okay? I'm going either, I can draw across, then down, or I can go down, then to the right. It doesn't matter, okay? The biggest thing that I'm looking for is from this point where they intersect, how much is it moving in the Y? And then how much is it moving in the X from that? From point to point, how much am I moving in my Y? And then how much am I moving from my X? So, I'm changing by how many? So I go 1, 2, 3, 4, 5.
You went down, so it's negative.
Well, hold up. And then I'm changing the X by 1, 2, 3, 4, 5, 6, 7, right? Y'all agree with what I did there? Move this up a bit more. Okay, now. How many of y'all are familiar with a thing called slope? Anybody? All right. This is sloping. Okay? This is every slope that you will encounter. Okay? Positive slopes from left to right go uphill, right? Negative slopes from left to right go which way? Down. So that's his eyebrows and his eyes. What is its nose in that bridge and then the nose part represent?
Down there?
No. Vertical line. Here's a vertical line. Vertical lines have a slope that are undefined, right? What does his mouth symbolize? No. What type of line does his mouth symbolize? Horizontal. What's the slope of a horizontal line? 0. Look at the corners of his mouth. They're what?
0.
That's right. So slope man identifies the 2 special cases, right? Plus your positive and your negative. Okay? So here's what I'm talking about. So slope is changing Y over changing X. It's 5 over 7. Now I'll put my sign to it, right? I'll put my sign to it. Because if I did this, if I come over and then, well, come over and then down like this, people get confused about what is what, okay? So I normally put my sign on afterwards. If I were to connect these two, which way from left to right would it be going? From left to right, it would be going downhill, correct? So therefore, it must be a negative 5 over 7. Questions? Y'all okay with that? How many of y'all have seen slope man before? No? You have now. Kid, you could draw it like that, right? Yeah. So you can be a happy slope man or a sad or a mad slope man. It doesn't really matter. Yeah. Okay. Anyway, any questions on that? That's a good strategy. It's got everything you need right there. So highly recommend that. All right, so let's look at this. Find the slope and the y-intercept from the line. Write the equation in slope-intercept form. Well, first off, slope-intercept form is y equals mx plus b. The 2 players that I need in here is the m and the b. M is the slope, and then the b is, guys, y-intercept, right? So those 2 things are needed in order to write this. So let's see if you can take the previous information that we just looked at and apply it to this. I'll give you a minute. Go. You should be able to pick up the y-intercept pretty quick, right? Where the line crosses the y-axis. So that will always be my starting point, right? Okay, now all I gotta do is find out where it crosses it perfectly again. So not there, not there, not there, right there, right? So all I wanna do is just kind of makeshift triangle, right? Or a step. How much am I moving in my Y's, and then how much am I moving in my X's? We know it's a positive slope. Why?
Because it's going up.
That way. No. Be more descriptive than that.
We're moving left to right, it is going.
It's increasing, right?
Yeah.
It's going up from left to right. So, yeah. All right, so if I look at this, I'm changing 1, 2, 3, 4. And then on the X's, I'm changing 1, 2, and 1.
3.
So if I look at this, the slope is changing Y, so it's 4/3, right? Any questions? It's positive 4/3 because it's positive slope going uphill from left to right. So I'll turn around and place this in. Okay? And that is my equation. Now, please don't ever, when somebody says, what slope is that? Please don't say 4/3 X. X is not your slope. Don't ever say X will slope, right? Slope is always your coefficient, correct? Yes? All right. So, misunderstanding on things. People think the X belongs to the slope. No, X is just a variable, right? Okay. I think with doing this, we've answered all the problems or the questions below it, right? Correct?
Yes.
How do we do on that? Be able to do that? Feel comfortable with it? Excellent. All right. Note that we used our step, right? Kind of like made a triangle. Didn't matter if it was above the line or what? Below the line. Doesn't matter how you draw that. Okay. Well, if I can give you a graph, I can also give you 2 points, right? Again, equation, find the equation line with x-intercept -2 and y-intercept of what? -5, right? So, y equals mx plus b. I need the slope, and then I need the y-intercept. And if you look right here, I have the y-intercept, right? That is what? -5. So I'm going to let you solve for slope. Okay? Take about 30 seconds, find the slope, and go ahead and write the equation. Go. All right, how did you find slope? Made a graph, that's good. You can do what's called an Etch-a-Sketch, right? Make a Cartesian plane, project Y's, and put little dots, and then just count, right? Anybody else do anything? The stacking, right? You can do the stacking here, which is just basically using the formula, right? And so this would be changing X, and that would be changing Y. So from -2 to 0, that's going up the number line, right? 2 spaces. So I'm changing it 2 for the X, right? And I am decreasing by 5 on the Y. And if I look at this, I have changing Y over changing X, which is -5 over 2. I've got a negative divided by a positive, so my overall slope will be negative, right? Can I simplify 5/2? Not from a fraction standpoint. I can convert it to a decimal, but that'd be about all, right? So when I write this, it's -5/2 X minus 5. How do we do? Y'all good? Yeah, feels good, right? Linear is a tough topic or concept to grasp. That's really the foundational functions. But once you grab that and understand it, it's easier to build off. All right, moving right along. Find the equation line that passes through these pair of points. Right? Anytime you have 2 pairs of points, or 2 points, you can find or write the equation of a line. They want you to write it in slope-intercept form. Okay? So what I want you to do is I'm going to give you about 45 seconds. I want you to find the slope. Then I want you to figure out a path to find the B, right? Or what you're gonna do. Don't do it, but I want you to have a plan, okay? So find slope, be ready to go. Okay, so depending on whatever method you use to find slope, whether you plotted the 2 points and done your little stair step or half of a triangle, or if you did y2 minus y1, or if you stacked them and looked at change, you should have got -2 as your slope, right? Let me introduce you to one of the most valuable equations around. It's called point-slope form, okay? The reason it's called point-slope form is it requires a point and a, guess what? That's right. So here's my point. There's the negative y1 and the negative x1, right? And then I've got slope. Well, the slope is not hard to put in, correct? So I got equals -2, correct? That's not a problem. And I got x here and I got y there. So at this point, if I could put in an x and a y that comes from one of my points, then I've got it filled in, and then I can just distribute and move some stuff over. But I want you to pay close attention to my yellow dots. This is y minus y1. This is x minus x1, right? And if you understand when you subtract a number, it's actually doing what to it, guys? Well, when you're plugging a number into something that's being subtracted, what it's going to do, when you go y minus y1, you're putting the y coordinate in there, right? So when you're minusing a number, what it's going to do is it's going to change its signs. Okay, so the whole thing you've just got to remember is when I take an ordered pair, plug it in, my x and y both have to change signs. Period. No ends, no ifs, no buts, neither. It has to. Okay? So let's kind of look at my 2 ordered pairs. I got -1 and 1, right? Then I have 1 and -3. It doesn't matter which one I choose from here. That's the really cool part. Because both of these are on that line, right? So let's choose the first one, -1 and 1, right? So that's a +1 for my y value. Y'all agree? But when I plug it in here, it's going to become a what? -1, right? So that would be y minus 1 here. And if I look at my x value, that's a -1. When I plug it in, it's going to become a positive. So that's it. But watch what I'm about to do. This is what the benefit that you get from it, that a lot of times teachers don't tell you. All right, so I'm just going to use this one. So that would be -1, and that would be what? +1. Okay. Note that my y changed signs and my x changed signs. Now all I'm going to do is this: y minus 1 equals -2x minus what? 2, and then turn around and add my what? Look what I'm done with. When I get done simplifying or distributing, and I'm moving that number over to the other side, when I get done with that, it's not go back and plug it back into the equation. I have the slope-intercept form of the equation, right? A lot of times, the teachers will teach you find B, right? Take your x and y and your slope, plug it in, solve for B, and then rewrite the equation, correct? Okay. It's half one does another. But what is the whole purpose of point slope? It's the most underutilized formula or equation we have out there. But its whole purpose is to write the equation. You have a point and a slope, right? That's its whole purpose. That's why that formula came about. Okay? So utilize it. It's probably one of the most powerful things you can do. So, if you're stuck on this, y equals mx plus b, and you're sitting here and you're going, oh, I think I'll just take 1 here equals -2 times -1 plus b, and then you get this, right? Y'all remember this? So -1 equals b. Y'all remember that? Head nods, yay or nay. And then you have to go write it. Well, by the time you do all this, if you just do this, distribute, move it over, you've got the equation already written for you, right? Yeah. Work smarter, not harder. Highly recommend that. Okay? Any questions on this? So that's my go-to. Okay? Not the right-hand side here, but the left-hand side. So if you're on the right-hand side of the train, well, you're going to really hate it. Because I'm going to sit here and go town on that. Okay? So, all right. Boom. There's 2 points. Write me the equation, right? Go. You can continue working. I'm just going to write slope down and then we'll compare, okay? All right. -4 to -4. Did I move anything? No, that's 0. -4 to -3 gave me what? +1, right? -4 up to -3. So slope is change y over change in x. So that's 1 over 0. What happens when you have a 0 in the denominator? Undefined. So you cannot have one part or nothing. If you can, come with me and we'll make millions of dollars. Okay? It's like the fractions in pi, right? The denominator tells you how many things, and then the numerator tells you how many shades of it, right? So shade 1 of nothing. Can't do it. Ladies and gentlemen, it's undefined. Now we've got to write the equation based off this, right? Well, anytime you get a slope that is either 0 or undefined, you should know that you're dealing with a special case, right? So let's think about this. It goes up 1, but doesn't run anywhere. Then it goes up 1, doesn't run anywhere. Goes up 1, doesn't run anywhere. Goes up 1, doesn't run anywhere. What kind of line is formed? Oh, every line's straight. Yeah, that's the answer most people get. But if you go up 1 and don't move left or right, and continue going up 1, never move left, what kind of line is formed? Vertical. A vertical line, right? Think of it in terms of changing y over changing x, right? How am I moving? Well, if I'm only moving up, never left or right, then I'll create a vertical line. So what's the equation for a vertical line? Remember, the equation for a vertical line will be the axis is being crossed, and then where on that axis, right? So what axis is being crossed on a vertical line? X. The x-axis, where?
-4.
-4. Ladies and gentlemen, this right here should be a dead giveaway. Anytime you have the same coordinates in both of them, then you're going to know you're going to have a 0 change. And where your 0 change is, that's the variable being used, right? And that's the number. Just think about it. X equals -4. It says, for no matter, if you looked at it from a T table, for no matter of X, well, for no matter of Y, your X is always what? -4, right? I can pick whatever I want to from Y, but my X better always be who? -4. That's what that means. Okay? So we're good? That special case is going to sneak up and bite you, right? All right. How many of y'all got that? Just curious. All right. Okay. How many of y'all are like, ooh, I got slope is undefined. I got that. Yeah. All right. Okay. Draw a line through the given point. Draw a line through the given point and parallel to the line displayed. Well, first off, if I've got to draw a line through this point right here, then I have to have another point, because a line contains at least 2 points, right? The big thing that they said here was the 2 lines are what? So what does that tell you? The slopes are the what? So the slope for line 1 is equal to the slope for line 2. Well, all we have to do is go, let's figure it out. Let's always pick, and 9 times out of 10, when it goes across the y-axis, it's going to cross that perfect grid, right? So that's going to be my starting point. Where's it crossing again? Right there? Looks like it crossing there? Yeah? All right, so how much am I going up? 1, 2, 3, 4. And then how much am I going over? 1, 2, 3. So if I go from here up 4, 1, 2, 3, 4, and go over 3, 1, 2, 3, if I connect those dots, guess what, ladies and gentlemen? That's right. Because if they change the same amount, a linear equation has a constant proportionality, a constant rate of change, right? So therefore, if they change the same amount every time, they'll never touch, will they? If I move 5 and you move 5, we'll always be how far apart? How about that? That's pretty cool right there. All right, y'all good? Excellent. So I'm going to hush and let you do this. Draw a point through that line that's perpendicular to that right there. That's a highly used word right there. So go. Okay, y'all ready? First things first. These 2 lines are what? Perpendicular, right? So if L1, line 1 is perpendicular to line 2. Y'all know the upside down T is perpendicular, right? Y'all remember that from geometry days? Then we should know that one of the slopes has to be positive, the other has to be what? And then they have to be reciprocal to one another, right? So when they get multiplied, their product would be -1, right? Okay, so let's find the slope of this one. So I'm here, let's see there. So I'm going up 1 and over how many? So the slope for line 1 is up 1 and over 2. It's a positive slope, right? Yes? So the slope for line 2, if it's perpendicular, well, first off, I know it better be what? Thank you. It's going to be a negative. Now, what's the reciprocal of 1/2? 2 over 1. Okay? Yeah? Okay. Now, -2, I'm going to go down and right 1. So down 2 over 1, right? Yep. I'm looking at it crazy. That doesn't really look like it's perpendicular, does it? Does it? Or is it just
messing me up.
Is it messy?
It was messing me up when I was looking at it. I was like, no, that can't be right.
Yeah or nay? Y'all got the same points I did?
Yeah.
Yeah, it has to be that, right? Up 1 over 2. Flip, full moon, yeah, positive, negative, right? Down 2 over 1, down 2. Here, okay. Is it?
You can't even turn the sheet.
You turn it? Yeah. You know what's kind of throwing us? See that point right there?
Yeah.
That's what's throwing us. Yeah. Look at that baby right there. Woohoo! Grab this here. That's perpendicular, right? Yeah. Good? Yeah, it is. Mathematically, we can prove it, right? 1/2 times -2 over 1, that better be what? -1. Ching, we're good. Correct? All right. Any questions on that? So you got the graph line, it's parallel, one is perpendicular. Okay, so given the equation y equals -5x plus 4, which of the following equations have a graph parallel to this?
same road. That's not plus 4.
Does it? What's it gotta have? What are we looking at? Just the slope. So what's the slope of the first one? -5, right? So every one of them that has a slope of who?
105.
No. Whoa. This is who?
Parallel.
Parallel, which means the slopes better be what? They better be the same, right? That's right, -5. So, hey, look at that one. What's that slope? -5. What about this? No. What about that one? No. What? That one? How about this?
No.
How about that one?
No.
So, how many up there were good?
2.
2. Since select all to apply, right? Ladies and gentlemen, what do you think they're doing here? And they're not sitting there trying to get you confused. But,
Just trying to make sure.
yeah, they're trying to make sure you understand the difference, being able to recognize what a parallel slope and then what a perpendicular slope. Because that is a key point. That is a major point when it comes to understanding this, right? Y'all good? Just 3 more problems. Okay. Find the equation line using point slope form. Hello. Write the final equation in slope intercept form. It's parallel to this, but passes through what? Through that point, right? Okay. We'll give you a 45-second head start. Go. Okay. So let's pull the slope for the first one, right? The slope is 3. If they're parallel, they have to have the same slope. Y'all agree? Okay, good. So that's where this is going. Now, I've got -2 and -5, right? So that's my X and Y. What is the main thing I got to understand when I'm using point slope form? Signs change on the who? Coordinates. The X coordinate and the Y coordinate. So when I plug this in, this is -5. When you plug it in, it better be a what? Positive. This is a -2. When I plug it in, it better be a what? Distribute. So that's 3x plus 6 on that side, y plus 5 on this one. Subtract 5. Y equals 3x plus what? Done. Okay? I think it's more efficient, quicker to get to where you need to go. It just makes sense. Fair enough? Any questions on this? All right. Let's see what you can do with this one. Find the equation line given the information. Slope is undefined and it passes through that point. You have 45 seconds to answer. Go. All right. If you understood slope, man, the 45 seconds was kind of not necessary. Because it said slope that was what? Undefined, right? Slope that was undefined. Which means, if you're looking at slope, man, which one has the slope is undefined? A vertical line. Look at his nose right there, right? There's the U. So, what is the equation for a vertical line? X equals what? -4. The X value, right? If this said the slope, let's just go ahead and kill 2 birds with 1 stone. If this happened to say slope was 0, let's for grins and giggles. Slope was 0 and passes through this point. Then what type of line has a slope to 0? Get your math right there. Horizontal, which is what? Y equals. Well, it'd be what?
0.
The 3, the Y value, right? Because it says no matter what that value of X, Y would always be what? 3 for that, right? So, yeah, we worked the first one, right? But we also took care of the other special case, correct? And you're going to see that. Guaranteed. All right? So make sure that you're solid with what this is. Draw it out, put it on a little note card. right? All right. Any questions on that? You know what's coming, so be prepared. Last one, right? Find the slope of the line and pass it through the given points. Enter D and E if slope does not exist. What would D and E be?
Does not exist.
Yeah, but what would it? It would be it's what? Undefined, right? Could you have a slope of 0? Would it still exist if it was a slope of 0? Yes. It's only if it's undefined would you put D and E. So you got 2 of them, right? So find the slope of both of them. The first set and then the what? Second set. And then we'll basically what it's asking you, the lines are what? Parallel, perpendicular, or what? I don't know what the third choice would be. How about this? Neither. All right, I think that would be the third choice. Okay, see if you can find it. Take about a minute to do both of these slopes. By now, you ought to feel comfortable about finding slope, correct? All right. So looking at this, the first one ought to give you a slope of -1/2. The second one gave you a slope that was 2/1, right? What can you say? What can you say about these two lines?
Perpendicular.
They're what?
Perpendicular.
Perpendicular, right? Okay. Now, any questions on this?